Alabama. I'm a network security architect. I focus on designing large, complex networks for telco service providers, critical infrastructure, SCADA, large enterprises, and I'm either designing, securing, or figuring out how to break into networks. So I focus on network infrastructure, all facets of it. And so what we're going to cover today is some ideas, if you're into red teaming, pen testing, some ideas that you might not have thought about when you get access to a router for an organization, some things that you might be able to do with the router to escalate your privilege on the network, and also some ideas for defenders, some things that you need to be aware of if you haven't thought about before as a defender. So how are we going to possibly gain initial access to the router? One example we'll cover that might get that initial access to the router that enables you to start doing additional pivoting across the infrastructure is, say, for example, we have a router over here on the right, and the organization has applied access lists. They've locked down the trust relationship. They only trust, say, the network management system down here at the bottom. They've got strict filtering at the router inside that internal enclave there. But somebody forgot to possibly put in like anti-spoofing measures at the perimeter edge of the network. And so what you might be able to do is, if you've done a good job of doing recon, info gathering against the organization, it's possible that you could use a tool like SNMP Blow to create SNMP packets that are going to spoof the IP address of this network management system that is trusted by your routers here, and feed a custom dictionary that you have developed by way of gathering intel recon against the organization, and combine that with in your SNMP Blow script here, direct it toward that targeted network, and it's going to run through that script spoofing UDP SNMP packets of that network management station and firing at that router. And if you're able to guess the SNMP community string, which is basically the password that's used to manage the network devices, if you're able to guess the correct password, community string, then you're going to download the router config. And once you've downloaded the router config, now you have all their information. You've got their the radius server IP addresses. More about their network management infrastructure, their logging, username, passwords, and additional trust relationships, the routing, other access lists that they may have filtered. You'll also be able to use the same kind of technique to upload a new config to the device. So that's how you might get an initial access to the router. Once you get access into the router, everybody knows about doing the typical layer 2 attacks, that first hop attacks, like ARP poison, the classic layer 2 stuff. But one thing you might be able to do if you gain access to the router and you want to be able to influence traffic across VLANs, you don't want to go and say do a classical ARP poison type attack inside of a VLAN that you may have access to. You want to go in and influence traffic across a VLAN. Well, there's a capability called policy routing, utilizing route maps and access lists on Cisco routers that allow you to override the routing table for the router. And so you could go and develop a policy based on a granular defined access list that's going to specify the traffic that is of interest to you. And you could use a route map to override the routing table to redirect traffic to yet another VLAN. And then after you've gotten a copy of the traffic, sniffed it, done your packet capture, you might be able to forward it on back to the original destination after you've accomplished whatever your goal was, all in your VLAN. So that's one thing that you might be able to do with a router. Once you've gotten access, you might be able to force a backdoor connection, force traffic that is of specific interest to you. If you want to avoid getting caught on the egress, because most people put all their visibility, security monitoring at the perimeter edge, and if you want to bypass that perimeter edge and have the blue team, the defenders not catch you going out the perimeter edge, maybe you have some kind of 3G, 4G backdoor or Wi-Fi connection, and you force traffic using the route map to take your backdoor connection that you have set and override the routing table. You wouldn't want to use that very open policy, because you're going to send too much traffic out that back door, might grab some attention but using an access list that's very granular, you could specify only traffic that is of specific interest to you to go out that back door. Now, also at the perimeter edge, someone that has access to the network and they may have influence up into the cloud, say one of your telco service providers, they may go and reconfigure your router for you so that if traffic of certain interest will override the routing table and force it out one of the paths to the internet. Say if you're multi-home running BGP, maybe we override traffic of a certain interest to head out because we have influence in the cloud. A lot of you guys that have been around the hacking community for a long time, especially the routing, are familiar with Gre tunneling. And you might be familiar with being able to turn on Gre tunneling, where we, in the old days of networking, we used to use Gre tunneling to transport non-IP protocols like IPX, DECnet, XNS, LAT, etc. across an IP backbone. You can use that policy routing that I just mentioned. You can combine that with Gre tunneling to override the routing table again and force traffic that's interested to you over the Gre tunnel and terminate the Gre tunnel at a router that you own and be able to sniff the traffic that is of interest to you. And that's very well documented in this Symantec paper. It's pretty well known. It's been out for a long time. But something that I have not heard talked about in the security community is, along the same lines, is using a new capability called ER-span to be able to mirror and send traffic out. We all, everybody that does network support, runs network operations, is familiar with doing span on a local switch or R-span between switches to be able to sniff traffic. Well, one thing that you could also do is ER-span, where you can mirror traffic out to an IP address. And so if you gain access to a switch router that has the code that supports ER-span, you might be able to use ER-span as a way to exfil traffic out the network. Now you're going to, depending on the network that you're mirroring, you may be sending out an excessive amount of traffic out that perimeter path, so you got to be careful because you end up getting busted if you send too much traffic. But it's something to be aware of. The next router I pop, I'm going to use this on them, just because. Another idea is back in the day, when I first got into routing real heavy, built out a SNA network for a customer. This is a nationwide network, ended up being about 143 sites, and we were doing SDLC protocol over IP using DLSW, and basically allows you to tunnel SNA and IP over an IP backbone. Well, actually DLSW, SNA, and NetBIOS over an IP backbone. And how it works is what is not turned on for routing is going to be bridged, and SNA and NetBIOS are bridge protocols, so you got the IP routing turned on, you turn on the DLSW, and your SNA and your NetBIOS traffic would be bridged over, and that's the whole concept, and it works pretty great. But your bridging, and the way the routers work, if you turn on bridging and you enable routing, any protocol that is not enabled for routing and you have bridging turned on, it will bridge it. And so that got me thinking about IPv6, because IPv6 is turned on so many networks by default. You go into many networks and turn on, Wireshark, TCP dump, et cetera, and you just see the IPv6 multicast on the wire, as Eno and the ERNW team talked about earlier this morning. You see that all across the wire, and got me thinking about what is another way to tunnel IPv6 once you get a handhold into a network? What could you do with it? So if you got access to the router, one of the things you might be able to do is turn on DLSW if they have the feature set in the router. And most likely, with the proliferation of voice over IP today, they probably have a feature set on the router, though they don't have a need or requirement for SNA. The code is there so that you could turn on DLSW and do IPv6 tunneling via DLSW from site to site across an IP backbone. It may be a new tunneling method that nobody's looking for. A lot of people are going to be looking for the classic IPv6 tunnels that are covered in the RFCs, or they're covered in pretty good detail in Scott Hogg's book on IPv6 security from Cisco Press. Well, this is one that's not documented anywhere that you might be able to bridge IPv6 across with. Another idea, if you gain access to the routers, you're out doing pen testing, is this L2TPv3 protocol. Something that you might want to take advantage of if the routers are running the feature set. And of course, if they don't have the feature set running, if you got access to the router and they got the memory and the flash to store it, upload a new OS for them so that they do have the feature. But how L2TPv3 works is, I come from a carrier background, large part of my career, and we would use L2TPv3 to backhaul layer 2 traffic, say PPOE, for say a dial-up customer, for wholesale dial-up, for say an application like AOL, where they don't have telco facilities around the world, and they could go and terminate your PPP connection locally, your dial-up, and then backhaul it to their data center, where they would terminate all their dial-up customers, DSL customers, et cetera. And you could tunnel that over L2TPv3 as an option. Well, and what the concept is basically called a pseudo wire, where you can drag and drop a logical Ethernet connection across a routed network from one network to another network, so you can make a VLAN appear across a heavily routed network, just like it's all one big flat network. It basically extends your layer 2 broadcast domain across a wide area network. And so that got me thinking, if I can get access to the router, if we can get access to the router and they have the feature sets loaded, why not go and create an L2TPv3 tunnel and enable all the classic first hop layer 2 attacks over a wide area network? Everyone assumes that you have local access. I mean, how many organizations are resisting and fighting implementing port security? I mean, you go pull up Wireshark, TCP dump on just about any LAN, and you see all of the spanning tree. You see all the first hop protocol. You see all the IPv6. You see all the low-hanging fruit. You see the first hop redundancy protocols, just multicast on wire. They're screaming for somebody to hack them, but everybody goes and writes it off their mitigation as a low priority because you got to have physical access, right? Well, what if if you get access to the router remotely, maybe over the wide area network remotely, you can start attacking those layer 2 protocols just like you were on the local LAN. L2TPv3 might be one of the methods that you could use to do that. Hey, another methodology you might use if you can gain access to the router, FX, Felix Ledner wrote a paper that goes into a lot more detail than I'm going to here. I recommend, if you want a great more detail on lawful intercept, to go check out FX's paper on, but basically the concept with lawful intercept is A and B are having a conversation, and we're sending traffic between each other, and if you turn on lawful intercept, which is what the law enforcement uses and governments use, to be able to tap a network connection, a perfect copy of that communication is going to, say, the law enforcement or a federal agency, a government agency that is interested in sniffing that traffic without anyone knowing what they're interested in. So you're having a communication and a perfect copy is being sent off. Now, how the telcos ensure that the right people are getting the wiretap, so when the government authorities come in and they request that capability, how they make sure that the right traffic is being tapped is using, in some cases, they either use PPOE with radius so that they can tie an IP address back to a username and they know that the right person is getting, their traffic's being tapped, or if it's a DHCP environment without the PPOE and the radius authentication, they might be using DHCP option 82. And what happens is when your computer from the cable modem or say a fiber to the home or DSL, when your device comes on the network and sends out a DHCP broadcast request, the option 82, you have DHCP snooping turned on that edge device at the telco perimeter edge, and it injects into that DHCP header the chassis name and the physical interface of that device that received that DHCP request, injects it in the header, and then it sends it up northbound to the DHCP server, where it will log that in its logs. And so when the government comes in and they need to go do a tap for law enforcement purposes, then they know who they're really dealing with, so that the wrong person doesn't get accused of a crime or what have you. And it's also, I recommend to the blue team guys, the defenders, to check out using option A2 if you're using DHCP in your environment, and you're having trouble tracking down users in the network when you have an IP address that goes rogue, especially in these really large flat networks, check out using DHCP option 82, where you can turn it on your network infrastructure out the access layer, where you can more easily track those users down to what closet they're coming from and down to the actual switch port or the access point that they may be coming on the network from. It's a good way to track down problems. But if you're getting access to that router, one of the things that you might do is enable the lawful intersect capability if they have the feature set. If they don't, my experience is if you're able to grab a hold of somebody's router, they most likely do not have the wherewithal. They don't have the configuration monitoring, the health and status set up properly. They're not going to know it when you go and load a new piece of code on the router. So if it's inside your rules of engagement that you can modify their network infrastructure, that'd be a key thing is you got to make sure it's in your rules of engagement, or they're not going to be very happy with you. You start, rebooting their network infrastructure. If it's inside your rules of engagement, you could go upload a piece of code for them that has the lawful intercept feature sets, and maybe enable the capability that you can go and start specifying the traffic that is of interest to you and start copying it. It's another a vector to think about and consider. Now here's a more complex scenario. We're involved with a red team engagement. Had an organization. They were in the cable TV business. Had a cable head in, and basically when you talk to organizations, you've got to know their nomenclature. If you talk to enterprise, it's a data center. You talk to a telco, their data center is a central office. You talk to the cable guys, they like to call it a head in. Well, this was a cable head in, and they have all their middleware, their analog digital receivers, billing systems, the video on demand architecture, and they're pulling digital signals, digital cable TV channels from an upstream provider. They're only using the off airs, the analog, locally, and then they're pulling digital signal from an upstream provider that is invested in a large head end. And the managed IPTV provider up here in the upper left-hand corner here, they're multicasting video content to this head end, and they're doing it for lots of different customers. And how this network is architected is with multicast, you got this rule called reverse path forward, and for these guys to receive that multicast traffic, they have to have their routes pointed back to this hosted provider so that the multicast will work because of the reverse path forward rule. Now we got engaged to do a pen test against this organization to see how far we could go into the network. And so we come in and we end up with access to this router here. And I knew that we had all this infrastructure back here, but we could not get an end-to-end connection. We're in the router, we're logged in the router, and we can go and look at the ARP cache, and we can see a very rich target set. And we start looking up MAC addresses, and things are resolving to Sun. MAC addresses are resolving to HP. And so the lights are going off me. I'm starting to think we've got a bunch of old Solaris boxes here, probably haven't been patched, probably running some old Oracle. It's probably a really broad attack surface if we could ever get a bi-directional connection into that network. And from the router, we could establish connectivity, but we could not get connectivity from the internet through the router. And it was because of the routes over here in the head end. The head end is pointing back to the cloud. And so there's not a path back. So what we figured out you could do, a nifty little trick if you ever find yourself in a situation, is we turned on NAT here at the edge and set up some static NAT translations from the perimeter edge back into the cloud, and the router proxied the connection for us. Even though their routes were pointing out here to the world, we were able to go and establish a two-way connection to host here through the router by turning on NAT and doing a static NAT translation. And basically, we're able to compromise numerous systems. Now, another thing you might be able to do, we see this often whenever we go out and do pen tests, and we get somehow get access to the facility. Either you red team and physical access is part of the engagement, or you're permitted to come in and have physical access. But when you get in the local LAN, we see OSPF. And how OSPF works, if you're not familiar with it, we have a concept. You have a router called an ASBR router that would be out at the perimeter edge of your network, where you might be talking to other networks that are running other protocols, say BGP. You might be tied into a different routing domain because of a merger acquisition, and they run in other IGP protocols, say like ISIS, EIGRP, but typically it's going to be BGP. And then you're going to have your internal routers, and you're going to start breaking up your network, depending on the size, into multiple areas. And you're going to have an area 0 that's going to be required, and then you have other areas that will be interconnected to area 0, so that you can segment your network out and spread your policies out for both routing and security across your wide area network and LAN. Now, from a pen test standpoint, what does that mean to you? Why do you care? What I have seen in my professional career, since I've been in this business since '99, wherever I get access and I can see the OSPF traffic, it is low-hanging fruit. And the network security teams, the auditors, whoever's coming in and doing the compliance and auditing, are leaving this low-hanging fruit on the table. It doesn't matter how many years they've been under audits. This is always just there to pick up. And it might not be OSPF, it may be EIGRP. Sometimes you may see some RIP version 2. I was in a network 2 weeks ago, and it was RIP version 2 that I'm seeing. So it could be other protocols, but we're going to pick on OSPF today. And what you're going to see is that protocol out there multicast out on the wire. And even though you can use a hash on that authentication, typically what you're going to see is the multicast traffic out on the wire, and there will either be no authentication or the authentication will be clear text. And now, as we know, it's been published numerous times here lately, even if they're doing MD5, if you have the time and if you catch the hash during your pen test engagement, if you have the resources, go rent some resources at Amazon, go crack their MD5 hash, even if they're using MD5 now, and be able to join their routed network and advertise new routes into their network. And what do you want to do with that? What is that going to accomplish for you? Well, maybe we do a man-in-the-middle attack and inject routes and start to influence the network. Do some kind of man-in-the-middle attack. Maybe if it was inside our rules of engagement, my rules of engagement never permit denial of service, but it's something that needs to be accounted for anyway in our report, that the customer is open to those type of attacks to a DOS, even if we don't do it. Maybe we inject some new routes and do our attacks using IP addresses, say, start using some interesting government agency IP addresses to launch our attack. I was just talking to someone last night that had saw an attack about 3 hops out away from their network, where the IP address space was being sourced from a interesting government agency, and you go out and try to track it back. It wasn't used, but you could go and start using interesting IP blocks to launch your attack from, and the defenders, the blue teamers, are out looking out at Aaron, Ripe, trying to chase down the bad guys who owns that IP space, and they start seeing IPs from some government agency or something. They're going to be thinking it's out in the cloud, and you're on the inside injecting routes and launching your attack and spreading influence across the network. They never know what hit them until you get them a final report. That's an idea that you might use. And if you've gained access to the router, you could possibly just go reconfigure the router, add new routes instead of injecting routes via some kind of packet injection tool. Just go and reconfigure the router for them, configure their OSPF for them, add the networks right there in the router for them as, say, secondary addresses and inject it into the routing protocol. Or do some kind of traffic engineering to swing traffic a different path that you want it to go. But up here in the upper right-hand corner is a long list of tools that you might use to accomplish such an attack. One that I would encourage you to take a look at if you haven't never heard of before is at the Naval Research Lab. It's called CORE. It's a real nice tool. It's based on Quagga. It's a network simulation environment. You can download the VM and run it in VM Player, and fires up a large simulated network environment where you can run an OSPF, BGP, RIP, etc. And you could blow up a really large network, integrate it in with the local LAN that you have access to, And so if the defenders start trying to trace down the network and they start doing their trace routes, even if they start looking internal, you can have a large network blowed up inside of a VM that they're trace routing across. You could really mess with their heads. I think it's fun. I think it's fun. You know, it's psyops, right? You got to have fun, right? And you got tools like Loki you could use. You could go, if you got access to some iOS, Cisco iOS, you could go and use Dynamips, of course. Heck, go buy your router off eBay. Maybe just fire up Linux with with Quagga, or use Scapy, or say you could, if you're into Windows, you could download the Colosoft Capsa tool and craft some packets to accomplish that. Another attack that's all in the news is this BGP. If you're not following what's happening with BGP, you really need to. If you're not monitoring your IP prefixes that you own, chances are, if you're an interesting organization, if your organization is doing something of value economically, or your organization has another interesting characteristic, vertical market, say, your traffic, there's a good chance that your traffic is being hijacked. And how this BGP works is we segment it off as AS numbers, autonomous system numbers. Everyone is associated with an autonomous system number. Whether you're running BGP or not, your upstream provider is running BGP and advertising your routes for you. And so every organization that ties it directly into the internet has an autonomous system number. In Europe, you'd go to RIPE. In the US, we go to ARIN to get the same places you'd get your IP addresses, we go to them. I go to ARIN to get my AS numbers, and you'd go to RIPE. If we're multi-home to the internet is one of our requirements, so that we can go and do load balance and active failover of BGP. And so somebody's implementing policies for you and advertising this. And something that I want to call out to you, in many cases, there's meet points, co-location facilities, where all the carriers come together, and they will do a cross-connect, basically an Ethernet connection, might be copper, might be fiber, and it's just VLANs, just tying VLAN segments together. Ethernet connections could be routed, or just could be a layer 2 connection where they're aggregating on a big freaking switch, basically, at some places. And what I want to call out to you is wherever these meet points are, whoever has access to that big switch. In many cases, you think of it, I'm a Cisco guy, so I'm thinking Cisco Catalyst 6500, maybe a 7600 router, stacked with Ethernet ports where everybody's aggregating up. So whoever has access to this box has all the rich layer 2 capabilities available to them that's inside the enterprise. And some of these central offices where these meet points are, where customer traffic, where the telco carriers, the service providers, the cloud providers, where all their traffic is being aggregated together, some of them have the guards, gates, and guns, lots of video surveillance, lots of access controls, really intimidating, especially to someone that's not a physical security expert. It intimidates me. I don't want to go near it. They immediately, bust me. But there's a lot of them that don't look like that, where you literally go in and the door is kind of jimmied shut, and you go in and the cabling is running across the floor. It just looks like some spider webs out of some kind of a horror movie, of just the cabling going between racks and between customers that have got interconnects, and you can't hardly tell where one network connection begins and ends. That is really enabling someone to go in and do all the classical layer 2 attacks that we all know and love in the pen test business, right here on the core backbone of the network. But we all take it for granted from coming from the enterprise space. We used to just make it, just a magic WAN cloud on our Visio drawings. But all of that stuff that's in our local enterprise, they're vulnerable to it up in the cloud if they have not done due diligence. So that's where we got to go in and mitigate that trust relationship that we're inheriting, because there's no reason that someone cannot go and get access to this box and start doing things like the ER span, say lawful intercept, the L2TPv3, and enable all kinds of attack vectors and exfil traffic out of your network. Now here's what everyone's talking about if you're following the BGP hacking. Basically there's an inherent trust relationship out on the internet. if you're coming from, let's say, interesting parts of the world where people can be persuaded by organized crime or government agencies to configure the routers the way we want you to configure them, someone could go and start advertising your IP space and start influencing traffic to swing over to different routers and be more preferred. And if you're not looking, you're not going to know about it until somebody like Brian Krebs writes an article about it and publishes it in the, the Washington Post or the Register. And then oh man, somebody, then you get a call from a C-level exec that, hey, my traffic, why are we in the news? Because that's what's happening right now in most cases. People have no idea. And it's really easy because there's just an inherent trust relationship with BGP out on the internet. And if you're not monitoring it, you have no idea because you have no controls. If somebody wants to advertise your routes, they can do it if they have access to the BGP networks. Now there's protocols that we could go and mitigate and secure, like there's a secure BGP where we could, but I'm not aware. The BGP implementations that I'm involved with telco carriers, service providers, and enterprises, we're not doing that. We do the best diligence we can. And you could also, just like you could advertise somebody's IP space, there's nothing to stop someone from stealing your AS number, as well as your IP address, and advertising it. And basically, like I said, the longest IP prefix is going to win, and they're going to swing traffic over. Now here's some references. I recommend you go check out the papers from ERNW, Enos Group. They've done a great deal of research. Check out Felix Lindner's papers on high-end routing. Ivan has got iOS Hints out on Twitter. He's got a great deal of information available. And on the BGP attack, I highly recommend you start using, looking at BGP Play, BGP Mon, Renesas, Team Cumry, or if you got scripting skills, go develop your own tools to proactively monitor your BGP routes on the Looking Glass servers. If you're not familiar with it, just go do a Google on BGP Looking Glass. There's a lot of servers that you can get free access in and start monitoring the status of your BGP routes. Because if you're not looking at it, how do you know that someone right now is not capturing your traffic and doing something with it? That's all I have. Does anybody got any questions? Sir? The slides will be available. If you'll email me, or hit me on Twitter, I'll give you all the slides. It's all available. Any more questions? Well, I really appreciate everyone showing up today and supporting my talk. Thank you very much.